I think it is audible now.
Yes, sir.
So,
Yes, sir.
good morning
Audible.
all. Good morning all.
Good morning,
We
sir.
are now going to start the lecture. In previous lecture, we have learned about the binary tree, I think. Yes or no?
Yes, sir. Left aligned binary.
Left aligned binary tree. What does it mean?
सर कुछ नहीं सर.
In last lecture, we have started with the binary trees and we have seen the definition of binary tree. I'm just recapping the concepts that we have learned in the last class. So binary tree is a tree in which at most two children are there. It means it could be 0, 1 or 2 children. Okay, then we have seen various different trees that can be made up with the help of 2 nodes or the 3 nodes. Some properties we have seen of the binary tree, like the total number of the nodes at a specific level. Okay, total number of the nodes in the binary tree that could have. Then we have started the type of binary trees in which we need to learn about strictly binary tree, complete binary tree, full binary tree, extended binary tree, skewed binary tree, and similar and equivalent binary tree. So I think we have covered first 3. Let me please help out. We have covered 3-1. First 3-1.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So what is strictly
Yes,
binary
sir.
tree? Can anybody tell me what is strictly binary tree?
Which include more, oh, include maximum 2 children or 2
Or anyone else? What is strictly
complete
binary
2
tree?
children.
Anyone else? What is complete strictly binary tree? No one? So one has given the answer that at most maximum 2 children. So what is the difference between strictly binary tree and binary tree? In binary tree also we are saying at most 2 children, and strictly binary tree we are also saying at maximum 2 children. So both are same thing. So what is the difference between strictly binary tree and simple
सर
binary?
0 हो सकते हैं और 2 हो सकते हैं. 1 नहीं होगा ना.
So your language is not correct. It is not maximum. It is only either 0 or 2.
Yes, sir.
Strictly binary tree, it means 0 or 2 binary, 2 nodes only. No one node is allowed. No single node, single child is allowed for any of the node. Is it okay? Or in other words, we can say degree 0 or 2 only. Never the degree will be 1. Now, what about the complete binary tree? Someone else needs to tell. Other than that person who has just answered, someone else needs to tell what is complete binary tree. Am I audible to all or not? Or am I audible to one person only?
You are audible, sir, to me.
No one else is there in the class?
सर लेफ्ट लाइंड होता है कंप्लीट बाइनरी ट्री में. मतलब पहले लेफ्ट वाले फुल होते हैं फिर उसके बाद राइट को.
अजय,
Sir, left and right.
वेरी गुड. सो इतना सोच के बोलने की क्या जरूरत है? यू आर नॉट prompt. Why you are not prompt all one? Actually, I am seeing. Am I not properly audible? Yes, or I am not clear. I am not able to clear your doubts. आप लोगों को शायद समझ में आ रहा है, नहीं आ रहा है, मुझे बताइए. यदि कुछ इशू है तो मुझे बताओ बच्चे. If you are not able to answer, it means कि I am not able to convey. Tell me. You need to be communicative. Okay. So complete binary tree, it means कि it is a binary tree in which except the last level, all the levels are completely filled, and at the last level, all the nodes are left aligned. That is the actual definition of complete binary tree. So a binary tree in which all the levels except the last level are completely filled, and at the last level, all the nodes are left aligned. That is what the complete binary tree. Okay, now what about full binary tree? Someone else. अब इन 3 लोगों के अलावा कोई और बताए. What is full binary tree? These definitions are very important actually. That's why I just want to revise it. Please tell me fast. What is full binary tree?
So a full binary tree is a one in which every node has two children.
So what is
Sir,
complete
every
binary tree?
node other than leaves has two children.
So what is the difference between this like this one? This is a full binary tree. In this slide, what the tree you are seeing, is it a full binary tree?
No, sir.
No, sir.
So, but the definition you have given follows
Sir, except
that
the last level. Above the
0
last
or
level.
2. 0 or 2 nodes.
this is also 0 and 2 nodes.
Yes.
This is also they in this all the nodes has either 0 or 2 childs.
Sir,
So is this
except the leaf nodes.
So here also except the leaf nodes, it is possible. It is there. 2 nodes are there. Every leaf node must have 0 and other nodes are 2 children.
सर ये 2n-1 होना चाहिए या 2 की पावर n-1?
That is not my question right now. जो क्वेश्चन मैं पूछ रहा हूँ बच्चे उसको आंसर देने दो पहले एक बार.
सर फुल बाइनरी है सर.
Is it a full binary tree? No, it is,
Yes, sir.
it is not a full binary tree. It is not a full binary tree actually. It is only a strictly binary tree or simply binary tree. Full binary tree, it means ki all the level must be completely filled. That is the definition of full binary tree. That is that this one is the full binary tree. All the levels must be completely filled. Now in this tree, all levels have the maximum number of the nodes or not. यदि इसमें से कोई भी एक नोड गायब हो जाएगी तो वो फुल ट्री नहीं होगा. Remember that. That is what why I am revising it actually. ये concept जो है, like when you will go to solve for MCQs and such kind of interview questions, then these definitions will definitely help you out in that case. आपको differences समझ में नहीं आएगा कि full binary tree, complete binary tree, बहुत minor differences हैं इसके अंदर. And they definitely ask the question on these terms because they know what are the weak point of the students. जैसे हम लोग वाइवा में क्वेश्चंस पूछते हैं ना, हमें पता होता है कि स्टूडेंट्स को इसका आंसर नहीं पता होगा. ये वही चीजें हैं. That is why I am revising it actually. Why I am wasting 10 minutes on that again. So देखो बहुत माइनर से डिफरेंसेस हैं बच्चे. Strictly binary tree it means कि 0 और 2. So उससे पहले binary tree it means कि 0, 1 और 2 nodes. Strictly binary tree it means 0 or 2 nodes only. Okay. Then complete binary tree, all the levels must be completely filled except the last one. ये लाइन जुड़ेगी इसके अंदर, except the last one. And at the last one, all the nodes must be left aligned. It may possible कि in this also all the nodes must be completely filled, all the levels must be completely filled. In that case, it will become a full binary tree. So a full binary tree is always a complete binary tree, but a complete binary tree will not ensure the full binary tree, or need not necessarily be a full binary tree. Is it okay now? Till now, any doubt? So full binary tree और this strictly binary tree में difference समझ में आ गया? 0 and 2 यहाँ पर भी है, 0 and 2 यहाँ पर भी है. आप भी सही बोल रहे थे, लेकिन definition जो proper है वो क्या है? The complete binary, full binary trees, all the levels must be completely filled. That particular line must be added. It is a binary tree in which all the levels must be completely filled. Is it okay now?
Yes, sir.
Difference is clear.
Yes, sir.
अब आप लोग ना definition
Yes,
मत
sir.
रटो मत definition. आप just diagrams को ध्यान रखो. Like this is my suggestions to you, and I give that suggestions to all of my students. Like that particular DSA I am taking from last 4 to 5 years, and I have written a book also on that. Okay. So what I want to, मैंने आपको जब लिंक लिस्ट पढ़ाई तो भी मैंने आपको बताया था, जब मैंने स्टैक क्यू पढ़ाया तो भी आपको मैंने बताया था, you just keep in your minds the diagrams, and on the basis of that you are able to write the algorithms, you will be able to write the definitions and all. सो स्ट्रिक्टली बाइनरी ट्री का माइंड में रखो क्या होना चाहिए. फुल बाइनरी मतलब सब कुछ भरा हुआ होगा, फुल कंप्लीट ट्री, इसमें कुछ बचा ही नहीं है, कहीं खाली जगह नहीं बची, फुल है, वो ग्लास फुल हो गया. कंप्लीट बाइनरी ट्री लाइक इसमें हमें लगभग फिल रखना है, लास्ट लेवल को खाली रखना है, थोड़ा बहुत लेफ्ट अलाइन आएगा. मैंने वो वर्ड्स भी स्पेसिफिकली हाईलाइट किए हैं इन द पीपीटीज. आई हैव अलाइन्ड लाइक हाइलाइटेड लेफ्ट लाइन. सो इन कंप्लीट बाइनरी ट्री यू नीड टू रिमेंबर द लेफ्ट लाइन कीवर्ड. With the help of that, you can able to write the answer. Okay. So now next one is extended binary tree. Now extended binary tree. First is the diagram. Okay. Now let me again explain with the help of diagram. Then after I will come on to the definition. So now what you are seeing in this diagram? One tree is given to you. The another corresponding tree is there also. Now tell me. What you are able to see, what you want, what you are able to predict with that. Do not read the content above the diagrams. Okay. आपको क्या समझ में आ रहा है? What we are going to do with this diagram? इसमें क्या changes हैं?
Sir, we are extended the another tree.
Very good. We are extended. Very good. हाँ. और what else? इसके अलावा और कुछ predictions. One, we have extended that tree. By extension, it means कि we have added some extra nodes in it. Extension means
node add करते जा रहे हैं नीचे.
we have added some extra nodes in it. Now tell me, what other depiction could be there?
सर क्या सर ये एक्सटेंडेड बाइनरी ट्री इसका कोई एंड होगा सर?
बताइए इसके अलावा और क्या डिपिक्शन है बच्चे. जो पहले मैं क्वेश्चन पूछ रहा हूँ उसका जवाब दें आप. आपको मैंने क्या डेफिनेशन क्लियर कर दी अभी?
नहीं तो सर इसमें हम नोट्स नोट जोड़ते जा रहे हैं.
वो तो उसने बोल दिया अंशुल ने, और वो मैंने भी बोल दिया.
सर,
आपने नया क्या
Sir, can it
हाँ बताइए बेटा.
Sir, can it be a complete binary tree, sir, since all levels are full?
नो. इज इट ऐसा दिख रहा है क्या हमें फाइनल ट्री के अंदर?
नहीं तो सर.
कब तक ऐड कर रहे हैं हम लोग नोड? देखो लेट अस सी नाउ अगेन. चलो हम ऑब्जर्व करते हैं. फर्स्ट नोड, लेट अस नो दिस इज द फर्स्ट लीफ नोड. दिस इज 1. ओके. दिस इज 2. दिस इज लीफ नंबर 3, 4. जो नोड चेंज हुई हैं वो हम यहाँ लिख रहे हैं. 1 में मैंने कितने लाइक हाउ मेनी चिल्ड्रंस आई हैव एडेड इन 1?
2.
2 children.
Sir, we are adding till we are 2 children of each parent.
Yes, we are adding the nodes. Till then we have got 2 childrens of each node. और 0 तो by default है. Every leaf node must have a 0. So we are not concentrating on 0. Right now what we are seeing here, we are trying to add some new nodes. We are extend the tree in such a way that every node must have 2 childs. That is what the extended tree. That's it. So
सर आपके कहने का मतलब ये है कि एक्सटेंडेड ट्री को तब तक उसके जो उसमें चिल्ड्रंस ऐड करने हैं जब तक कि वो फुल बाइनरी ट्री नहीं बन जाए.
मैंने ऐसा बोला ही नहीं बेटा. क्या
नहीं सर, ये अपनी तरफ से
नहीं, अपनी तरफ से आप मत ऐड करो ना. पहले मुझे कंप्लीट तो करने दो बेटा. मैं आपको 4 बार बोल चुका हूँ आज भी. मुझे कंप्लीट करने दो पहले डेफिनेशन.
ओके सर.
या आप पढ़ा लो और मैं चुप हो जाता हूँ.
नहीं सर आप ही पढ़ाओ.
We are adding or extended the nodes. Till then we have got 2 nodes of each child. Now is this a full binary tree? Tell me. This one is the full binary tree?
No, sir.
No.
Is this a complete binary tree?
Yes, sir.
Yes, sir.
Yes.
Is this a complete binary tree?
No, sir.
2 मिनट पहले बताया मैंने. Complete binary tree means left aligned. Is this left aligned?
No, sir.
No, sir.
No, sir.
So why सब
No.
लोग कह रहे हैं कि is it a complete binary tree? It is not a complete binary tree. Is it a strictly binary tree? Strictly binary tree.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, it is a strictly binary tree. That's it. So what we are going to do is in extended binary tree, we can convert a simple binary tree into strictly binary tree. That binary tree is given to me in which the number of nodes or children could be 1, 0 or 2. Okay. Now here you are saying that the children's could be either 0 or 2. That's it. So I am converting a simple binary tree into strictly binary tree by adding some nodes, by extended the binary tree. It means कि strictly binary tree की definition होती है कि every node must have either 0 or 2 childs. So that's why, like in this, suppose I am having only one child, so I need to add one more child of that. Okay, here I am having only one child, so I need to add one more child of that. Okay, now this leaf node now needs to be added with 2 children. Okay, बिकॉज इसके कोई 0 चिल्ड्रन से तो हम इसके 2 बनाएंगे, तो हमने डेफिनेशन बनाई है कि हम जो भी नोड है उसके हम 2 चिल्ड्रन बनाने वाले हैं, और बाकी की जो भी लीफ नोड थी पहले उसके हम 2 चिल्ड्रन से हम बना देंगे.
So sir, we are specifying this the extended binary tree on the basis of new nodes we are adding.
Yes, definitely. We are extended the existing tree. The tree which is given to me, I am trying to extend it. Now difference देखो यहाँ पर, like the nodes which we have added should be in the square brackets, square boxes.
Yes, sir.
And all the already existing nodes must be in the circle nodes. Okay, so that is what the difference between the newly added node and the already existing node. So your diagram must also be in this way only. आपका diagram भी इसी तरीके से होना चाहिए. So already existing nodes must be in circle form, and the new nodes that you are going to add must be in the square brackets. And already existing nodes are known as internal nodes. In this, the definition is there. And all the new nodes that we are going to add are called external nodes. So external nodes must be in the square, and internal nodes must be in the circle one.
So sir, if we look at the complete tree after the modification, so is it a full tree? मतलब full binary tree?
You just tell me, is it a full binary tree or not? You know,
sir, after complete modification, each level is completely filled, sir.
No, you just see this tree, and is this tree is complete full binary tree?
No sir.
बच्चे यहाँ पर फुल बाइनरी ट्री में यदि होता तो यहाँ पर भी तो फिल होती सारी नोड्स. ये लेवल तो लास्ट वाला लेवल डज नॉट हैव फुल कंप्लीट नोड्स. This level completely filled, this level completely filled, this level 4 nodes, this level 8 nodes. Is at that level 60 nodes are there.
Okay sir, okay, got it.
So it is not necessarily कि हमें full tree मिले, complete tree मिले, कुछ भी मिले, हमें कुछ नहीं मिलेगा, हम नहीं बोल रहे, लेकिन हमें क्या मिलेगा? Strictly binary tree जरूर मिलेगा. That is what we are ensuring it. So the process of converting a simple binary tree into strictly binary tree is called extended binary tree. A binary tree, now we can come on to the definition. अब मैं definition पढ़ रहा हूँ. Now the binary tree with special nodes replacing every null subtree. Okay, every null subtree. It means this is a null subtree. इसके नीचे कोई subtree नहीं है. इसके नीचे एक subtree है. Okay, every regular node has 2 child. जो भी regular node, regular मतलब original nodes, has 2 childs, and every special node has no childs. So the node that you are adding must have 0 childs. So in this diagram you are able to see. Now let me clear the things so that you will be able to see again easily. Okay. So the red nodes, how many nodes children have? The red nodes के कितने children हैं? Every red node must have how many children?
कोई children नहीं है.
0 children हैं. And every black node has
2 children.
2 children.
Two children.
Black nodes जो हैं वो original nodes हैं. So we are ensuring in that कि every original node must have 2 children, and every new node that we are going to add, that is external node, must have 0 children. That is what the definition of the extended binary tree. Is it okay? Any doubt in this? Just ask, otherwise we can move ahead. We need to fast actually also.
Yes, sir.
Done? Okay. So extended
Sir,
in question. हाँ बोलो पूछो. Ask.
सर एक बार ये बाइनरी ट्री विद स्पेशल नोड रिप्लेसिंग एवरी नल सब ट्री, इसको एक बार रिपीट करना सर.
Yes, definitely. Very good. ये क्वेश्चन और पूछने वाला, क्योंकि ये these are technical definitions actually, and if you are not able to understand that terms, that then you need to ask. फालतू चीजें ना पूछें. देखो every null subtree means कि इस सबट्री को देखिए आप, क्या इसका सबट्री नल है? इस फर्स्ट नोड नंबर 1 का इसका कोई सबट्री है? सो इसका जो है हम नल, इसका सब ट्री नल है. That is what the meaning of this is with special nodes. Now we are going to replace this null subtree with some special nodes, and that special nodes are known as square or external nodes. अब क्या ये 2 नंबर नोड का राइट सबट्री है? नहीं है, तो इसके राइट सबट्री को मुझे बनाना पड़ेगा. ठीक है,
ओके
जैसे इसका लेफ्ट सबट्री है 3 का, नहीं है तो मुझे बनाना पड़ेगा लेफ्ट सबट्री. 4 के लेफ्ट सबट्री राइट सबट्री दोनों ही नहीं है तो मुझे बनाने पड़ेंगे दोनों. 5 का राइट सबट्री लेफ्ट सबट्री दोनों ही है तो दोनों ही मुझे बनाने पड़ेंगे. दैट इज व्हाट द मीनिंग ऑफ दिस एवरी नल सबट्री. एवरी मतलब आइदर लेफ्ट और राइट, व्हाटएवर इट इज. ओके, रेगुलर मींस की ओरिजिनल नोड्स. सो दिस इज द डेफिनेशन अगेन. एवरी रेगुलर नोड हैज 2 चाइल्ड्स. सो जो नोड्स ओरिजिनली दी गई हैं उन सबके 2 चाइल्ड्स होने चाहिए. इसका मतलब ऑटोमेटिकली ये होगा कि दे मस्ट बी इंटरनल नोड्स. एवरी गिवन नोड मस्ट बी अ इंटरनल नोड, and every special node that you are going to add must have be external nodes. External nodes से कितने चाइल्ड्स होते हैं बताइए? लीफ नोड से कितने चाइल्ड्स होते हैं?
0 child.
नो चाइल्ड.
0 child.
0 सर.
ओके, नाउ इज इट ओके? नाउ डेफिनेशन भी देखिए आप, है ना? सो नेक्स्ट वन इज skewed binary tree.
Sir,
Yes.
sir, in the previous slide, sir, the second point you told कि हम we are converting the extended binary tree into a strictly binary tree, not into a complete.
This is the problem. Now is it okay?
Yes, sir.
Okay. Any other thing you want to ask or modified? So next one is skewed trees. A skewed binary tree is a type of binary tree. Now, what do you mean by skewing? Skew actually. Skew से समझ में क्या आता है आपको? What is skew?
Sir, like stairs.
Stairs. आप ये डायग्राम देख रहे हैं?
Yes.
Like
सीढ़ियां जैसा है.
what you are able to, नहीं सीढ़ी तो जैसा लग रहा है, यदि सर्कल हो जाएंगे तो सीढ़ियां नहीं होंगी एक्चुअली. So what does the skew means कि एक तरफ होना, in one direction. So like we have 2 different trees right now. In first tree, all the nodes, all the left subtrees are there only, no left right subtree is there. Only left child are there, no right child is there in this. And in the second one, only right childs are there, no left child are there. Is it okay? So that is what the skewness means, skew in one direction only. So the tree grows in one direction only. Is it okay? So on the basis of that, we can divide the skewed trees into either the left skewed or the right skewed. Left means ki only left childs we are adding. There will be no right child of any node in the tree. And in the right skew tree, only right childs are there. There will be no left childs of a node, any node in the tree, any node. Whether it is a root node or whether it is a leaf node or whether it is an internal node. So these types of the trees are called skewed trees. Okay. There are 2 special kinds of skew trees, left and right skew trees. Okay. Now in this you can say like how many children are there? Maximum childs कितने हैं किसी भी node के? 1. So this is a kind of a tree only we can say at most 1 child is there. Is it okay? So it means 0 or 1. 0 तो by default है because every leaf node must have 0 child. So leaf कहीं ना कहीं end तो होना ही है tree का. So there must be a node with have the 0 child. Is it okay? Skewed child.
सर एक मिनट सर एक डाउट है सर इसमें आपने कहा एट मस्ट 1 child, 2 child भी हो सकते हैं. अगर 2 child हो गए तो सर ये लेफ्ट साइड वो राइट साइड की तरफ भी जा सकता है. इसमें केवल
ट्री मूव नहीं करेगा, एक ही डायरेक्शन में ट्री मूव करना चाहिए.
ओह
वेरी गुड. है ना, लेफ्ट चाइल्ड ही होंगे या तो ये राइट चाइल्ड ही होंगे. तो तभी हम बोल रहे हैं कि मैक्सिमम 1 चाइल्ड ही होंगे. क्या ये स्क्यू ट्री होगा बताइए?
No, sir.
नो सर ये इसका राइट में चला गया.
नो सर.
तो ये ना तो लेफ्ट स्क्यूड है ना राइट स्क्यूड है. ओके. नाउ कम ऑन टू दैट सिमिलर एंड इक्विवेलेंट ट्री. दिस इज अगेन वेरी इंपॉर्टेंट. So Similar tree, in short, I have written over there, same structure and shape. Similar means same. So both structure and shape must be same. Okay. But equivalent tree, it means ki if similar and same content also are there, then it is a equivalent tree.
मतलब सर स्ट्रक्चर सेम है तो सिमिलर है, लेकिन उसमें जो एलिमेंट है वो भी से अगर सेम है तो वो इक्विवेलेंट होंगे।
हाँ जी, सिमिलर ट्री मींस की स्ट्रक्चर एंड शेप सेम होने चाहिए, and equivalent tree, if it is a similar as well as the content of that nodes are also same, then it will be known as equivalent tree. So in equivalent, similar तो हो ही गए automatically, है ना, plus content similarity वाला feature भी एक add हो जाएगा इसमें. Is it okay? Now tell me, A, B, C, D, 4 trees are there. Which one are, like if we will talk about A and B, is it similar or equivalent?
No, sir.
They are similar. Sir, A and C are equivalent.
I am talking about A and B. A and B are similar or not?
No, sir.
नो सर,
A and B are similar or not? Is it
सर
like
ए एंड बी आर सिमिलर नहीं, मेरे में जो बात लग रही है सिमिलर तो है लेकिन इक्विवेलेंट नहीं है।
so A and B are not similar actually. They have
Yes.
not same shape or same structure. Okay, they have mirror images to each other, but in structure only. Again, not in content. So now tell me about A and C. What about A and C? Are they similar?
Sir, they are equivalent.
They are equivalent, sir.
They are
यस
equivalent.
सर,
Very good.
इक्विवेलेंट है।
They are equivalent, or then they automatically will become similar.
Yes, sir.
Similar तो होना ही है.
Yes,
Okay.
sir.
Now what about A and D?
They are
They are
similar.
similar.
They are similar only. They are not equivalent right now. So difference is okay. Similar means same structure होगा, same shape होगा, सब कुछ same होगा, but content different होंगे, like A and D. Okay. So similar trees could be A, C, D. C, D could also be similar. Okay.
Yes, sir.
But equivalent trees are only A and C in this particular diagram. So now we have learned about the different kinds of trees. So we have learned about strictly binary tree. Strictly means again 0 and 2 only. Okay. Complete binary tree matlab left align. I'm just remind that particular keywords that you need to remind. I'm just revising it. Full binary tree matlab ki all levels completely filled. All levels completely filled. Extended means ki दो तरह की nodes होंगी, circle और square. Skewed मतलब
Circular as no children and
Either
square
left
as.
aligned or right aligned.
Skewed
के
मतलब
लिए
कि this और this. Similar के लिए हमने बता दिया है ना. Similar के लिए हमने पढ़ा है content और shape, दो चीजें हम पढ़ रहे हैं. यदि shape same है तो वो similar है, और यदि वो content same है तो हम equivalent भी बोल रहे हैं. तो ऐसे याद रखेंगे हम लोग. Shape है तो similar है, content है तो वो equivalent भी हो गया. Computer engineering. ओके. सो ये स्लाइड से आपको सब कुछ याद होना चाहिए. आपको बाकी दूसरी 6 स्लाइड में जाने की जरूरत ही नहीं होनी चाहिए. ये ऐसे याद करना है आप लोगों को, रटने की जरूरत नहीं है बिल्कुल भी.
सर एक मिनट, इसको कंप्यूटर लैंग्वेज में बता दूं सर. जैसे तो कंप्यूटर है, उसमें हार्ड ड्राइव है, उनका साइज सेम है, वो 32 जीबी के हैं दोनों हार्ड ड्राइव, लेकिन उनमें जो कंटेंट है वो भी अगर सेम है तो इक्विवेलेंट भी है और सिमिलर भी है.
Yes, very good. Good example. Okay, thank you. Now we are coming on to the representation of binary tree. Every like data structure we have learned about the representation. Stack में हमने representation देखा था. How many kinds of representations are there for a data structure? Two. One is static and one is
Dynamic.
Similarly, in linked list we have learned two allocations, static or dynamic, or queue, static, dynamic. Similarly, in binary tree we are coming on to the representation now. So two kinds of representations are there: array representation or sequential representation, and linked representation. So first of all, we are coming on to the sequential representation. Definitely sequential representations will always use a array. Okay, so in this case we will use one dimensional array. It will definitely be useful only when the tree is complete or nearly complete tree. Okay, Now, this is only what we are talking about binary tree. Again, remember it, we are specifically focusing on binary tree only. So we are not trying to give the representation of the tree which can have 3 or more childs. Uska representation alag hoga. Right now, we are talking about only binary tree. Okay. So, इसका भी एक reason है why it is useful only the trees which are about to complete or full binary trees, because if we will simply use it for the skew trees, then almost half of the nodes will remains unfilled. Half of the indexes of arrays will remains unfilled. So loss of memory will be there actually. You will see how actually. Okay. Now, number of nodes. Yes.
So we are trying to represent the binary tree in a sequential representation with the help of 1D array.
Yes.
So 1D array is in a linear fashion. So
Yes.
how we are trying to implement a non-linear structure with a linear fashion?
That is the thing that you need to learn now. Good. अच्छा क्वेश्चन
Okay,
दिमाग में
sir.
आया, लेकिन we will learn how. Okay. That is the good beauty of that representation of array. Now we will see how. Now number of the nodes using the numbering scheme for a full binary tree, and the node that is numbered I will store the element in the position tree of I. That is the answer of your question. Read it again. Number the nodes using the numbering scheme for a full binary tree. So whatever given to me, I need to number every node, taking that thing in mind that it is a full binary tree. Okay, now what about full binary tree? अब यदि आपको पता ही नहीं कि full binary tree क्या है, तो you are not able to complete represent that tree. Tell me, what is a full binary tree?
So in which all the levels are completely filled.
completely fit into
It
childs.
means कि every node must have 2 childs except the last node. Okay, now the node that is numbered I, जिसका नंबर I होगा, वो किस इंडेक्स पे आएगा? उस ट्री, मान लीजिए ट्री इज एन एरे which tree is the name of the array that we are going to use for storing the elements of the tree. So tree वो array है, तो tree I इंडेक्स पर वो नंबर, वो नोड आएगी जिसका इंडेक्स या जिसका नंबर हमने I दिया है. Okay, now let us see how. Now let us suppose this is a tree given to me. Is it a full binary tree first of all?
No, sir.
No, sir.
No, sir.
No. Okay, so I will start numbering it in supposing that it is a full binary tree. First node is the root node. We will start the numbering from there, 0. Then definitely it's left child, sorry. Then 1. Then it's right child 2. Then come on to the next level. The number is 3. Number is 4. Number is 5. And number is 6. Please be careful. I have also given the node number to the node which is actually not existing. Is it okay?
Okay, sir.
By assuming that I am having a full binary tree, I am numbering it in this way. In this way, we will assign the number to each node. Is it clear? First of all, first step is clear.
Yes, sir.
Yes, sir.
Number the nodes using the numbering scheme for a full binary tree. So in this way, we will assign the number to each node. Now we will make an array. What we will do? अब जो array बनेगा, उस array में 0 index पे क्या होगा?
Root
node A.
1 index पे क्या होगा? B. 2 index पे क्या होगा? C. 3 index पे क्या होगा? D. 4 पे 5 E. 5 पे
X, Y, Z कुछ
Blank.
भी हो सकता है.
blank, null value. 6 पे F. And so on. In this way, we will store a non-sequential or non-linear into a linear data structure. This is a representation of the binary tree that we are given to us.
So we are storing the null at a unfilled address.
Definitely, it is blank. It means.
And we are going to fill it in the future with some value.
Yes, if required, we can use it. If required, we can use it. Suppose I am going to insert some node at the position number 5. Insertion के टाइम हम देखेंगे. So जब भी हम कोई node insert कर रहे हैं, मान लीजिए हमको बोला गया कि आप इस index पे as a left child of C you need to insert a new node. Then the new node will be allocated, and the index of that node will be 5.
So we are preoccupying the empty address or empty node, we can say.
We are assuming that every child of a node must exist, both left or right child. That's why we are pre-assuming, and we are giving the space of that node into the array, even if initially they are not there.
सर
तभी
बाद में
हमें
हम इस
तभी
इसमें
हमें बोला
नोड में
गया कि फुल बाइनरी ट्री के अकॉर्डिंग नंबरिंग करनी है हमें. So initially we have assumed कि we have all the nodes completely filled.
सर बाद में हम इस ब्लैंक नोड का यूज एलिमेंट को इंसर्ट करने के लिए कर सकते हैं, क्योंकि हमने मेमोरी तो उसके लिए एलोकेट ही कर दी है.
हाँ जी, ठीक है. Is it okay now?
Sir,
Yes.
so we have numbered and we have stored the elements in a 1D array. But what if we want to print the tree?
What is your question? How you want to print the tree?
With the help of a 1D array, how we'll print the same representation as we could see of a binary tree?
Okay, so how the linked list, actually in the C, it is quite difficult to print the tree in this form that you are seeing onto the diagram or slide, sorry. In this form of circles and edges you required, if you want to print all these kind of tree, then for that you need graphics. Actually graphics की libraries की requirement होगी आपको, तब आप जाकर के इसको print कर पाएंगे.
So as we have printed the star pattern in the C language in our first semester, so can we use that over here?
One way could be like that also, but in that case you need to maintain many loops, because which node is empty you do not know actually.
Yes.
Randomly for every different tree you need to have a different program.
So we can provide any another symbol for that if we have an empty address or something.
So like for that again you don't know na ki where the empty node is there. So for every kind of tree you need to write the different program.
So the kind of representation as shown in the figure of the tree, is it real or is it our imagination for our understanding?
Yes.
Or the same way it is
Imagine-
represented in memory also?
No. Same way cannot be there in the memory. It is for our imagination only. Like if you are thinking in that particular point of view though. Okay. But that in memory, it will always be stored in the form of like sequential representation, or what we will going to learn like linked list representation. अभी हम देखने वाले हैं linked representation also. अच्छा सोचो linked list कैसे represent होती है. मेमोरी में हमने सीखा है how the linked list is representing. Array or how many arrays are required?
2 array depending upon the members.
Very good. 2 arrays depending upon the members. It could be 3. Like for a simple linked list, it could be 2. How it could be 2? One is for the data.
And one is for
For next.
Very
Or
good.
in doubly
Similarly,
linked
the tree will be stored in. Similarly, the tree will be stored into the memory. We will see how. If the sequential representation is there, then the array will be used, and if linked list is there, then like how the linked list will be used, definitely we will see now. So in memory, it is not like in this way जो आपको दिख रहा है अभी यहाँ पर tree की form में. Is it okay now, Devanshi? Is it clear?
Yes, sir.
So next one is like with the help now in this sequential representation we have some interesting facts also. Okay, now can anybody tell me if the node is having the index n, so what could be the index of its left child? Formulas we
N minus 1.
Oh, very bad.
Sir, please repeat.
Left child of the node, suppose a node is having an index n. Okay, so I am asking कि what could be the index of its left child? यदि किसी भी नोड का
अच्छा
इंडेक्स
उसके लेफ्ट चाइल्ड को आप पूछ रहे हो जिस नोड जो nth नोड है.
बिल्कुल, जिसका इंडेक्स n है उसका लेफ्ट चाइल्ड का इंडेक्स क्या होगा?
n+1.
n+1 एक आंसर आया हमारे पास. और बताइए. You have a tree, you have indexes, you can calculate it easily. I am trying to give you a formula through which that you can easily find out the index of any number. Suppose a node is 1 index. इसका लेफ्ट चाइल्ड क्या आ रहा है, किस इंडेक्स पे आ रहा है बताइए?
3.
So formula is
n plus 2.
n plus 2.
plus 2.
okay. Now the node is at 2.
No, sir, it is not n plus 2.
Sir,
How
when
then
it is
second
5
node
for
will have
2, it will
fifth
be at
child.
5, sir. And for second
According
node,
to
it will be
their,
n plus 3.
according to your formula, it is 2 plus 2. It is 4. It should be at 4, but it is at 5.
Sir.
Sir, 2n plus 1.
That's it. 2n plus 1. So left child will be at the index 2n plus 1. Always it will be. You just assuming like 4. Find out the left child index of 4.
9.
It will be 9. क्योंकि 6 यहाँ आ गया, 7, 8 and then it is 9. 9 का लेफ्ट इंडेक्स क्या होगा? 9 into 2 plus 18, 19. Okay, now tell me what could be the right child index in the same case?
1 plus 2.
2n plus 2.
2n plus 2. Good. Now tell me what could be the index of parent if the index is n? If the node is at index n, what could be the index of the parent?
n
n by 2.
N by 2.
n minus 1 by 2.
N minus 1 by 2 actually. Have you got it?
Yes, sir.
Is it okay n minus 1 by 2 or any doubt?
Sir,
For 5 it will be 5 minus 1 by 2. It is 4 by 2. For 6 it will be 6 minus 1 by 2. It is 5 by 2. Again it is true. 5 by 2 means true. Index integer value. Is it okay?
yes, sir.
ओके सर. सर इट
Yes,
इज लाइक ए बायनोमियल थ्योरम, क्योंकि उस सर उसमें भी ट्री बनता था. आपको दिखाऊंगा सर एग्जांपल इसका.
ओके. राइट सिबलिंग नोड्स का इंडेक्स क्या होगा बताइए? राइट सिबलिंग नोड का इंडेक्स
n plus 1.
डेफिनेटली n plus 1. लेफ्ट सिबलिंग का
n minus 1.
n minus 1. Now let me clear the things. It is only when the indexes starts from 0. The whole formulas will change when we assume that index starts from 1.
Yes.
And the changes will be, tell me, in the case of left child, like first का formula क्या होगा यदि हम index
2n
1
plus 2.
No, it is only 2n. It is only 2n. For like now it will be like this actually. इसको रेड कलर से करते हैं हम लोग. It will be 1, it will be 2, it will be 3, it will be 4, it will be 5, it will be 6, 7, its left child will be 8, 9. Now you see that? Is it okay? Now is it 2n is okay?
Yes, sir. 2n is okay.
Now right child, for right child it will be
2n plus 1.
very good.
2n plus 1.
2n plus 1. Next, update all the formulas.
n by 2.
n by 2. Very good. तो मैं तभी कंफ्यूज हुआ था मे बी. राइट सिबलिंग विल बी, इट विल रिमेन सेम, n plus 1 and n minus 1.
Yes.
So please remember and please be careful when you are solving multiple choice questions. वहां ये पूछे जाते हैं कई बार, तो हमारा इंडेक्स कहाँ से गिवन है, you need to take care about that. The formula will definitely get changed if it is starting from 0 or if it is starting from 1. By default it always, if nothing is given to you, then you can need to use this for particular formulas. But suppose specifically उन्होंने बोला है A1 का, तो आपको ध्यान रखना पड़ेगा. Is it okay now?
Sir, please repeat the last formulas.
Because like it is when we are starting the indexes from 1, like in indexes, array of indexes may also start from 1 na?
Yes,
by
sir.
default, by
Yes.
default, we assumes ki it always is initiated with 0, but it may also start from the 1. So that is, suppose A is at index number 1. I have it highlighted with the red ink. B is at 2 index, C is at 3 index, and so on. D is at 4, and so on. So in that case, if we want to draw the formulas for the same, तो वो हम discuss कर रहे थे अभी. Is it okay? So if it is 1,
Yes, sir.
so it will be 2n. 2 it is 2n, 4 it is 2n, 8 will be 16, and so on. And right child will definitely be plus 1 only. Left or right sibling will remain as it is, but parent will again change, it will be n by 2 now. Like it is 1, so it will be 1 by 2. 1 by 2 is 0, and 2 by 2 it is, sorry, 1 by 2 is 1, and 2 by 2 is also 1. तो ये हमारा हुआ representation of binary tree. Is it okay? Sequential representation actually. Now coming on to the linked representation. Linked representation means linked list use करेंगे definitely हम. So
एक बार पीछे करना सर, लास्ट के फॉर्मूले में मुझे कुछ डाउट है. n+1 सिबलिंग जब एरे इंडेक्स 1 से हो. सर छोड़ो सर, बाद में देख.
now let's look at that linked list representation. I think आप लोगों को खुद को clear हो जाएगा. Once you see on that, you will be able to understand that.
Dynamic representation.
Yes. So every node, how many parts we have now?
3 parts.
3 parts. Previous
2
part,
pointers and 1 data.
Yes. 2 pointers and 1 data. And 2 pointers are left child and right child. So for every node, we have 3 parts. One is this information part, data part. One is that left child part. Okay. And one is
Right
that right
child
child pointer. Sorry. So 2 pointers and 1 information field we have. Now you see, if the left child is not there, then what we are putting over there is
Null.
Null.
same. If the right child is not there, then what we are going to put over there is null.
Null.
So for leaf nodes, both the pointers will always be null. And suppose internally we also do not have, suppose C has no left child. So C का left child क्या हो जाएगा? Null.
null.
यदि F नहीं है तो हम बोलेंगे null होगा. यदि suppose F नहीं है तो
It must be a leaf child, वो leaf node.
So it could be a structure for your binary tree.
So sir, we should always use a doubly linked list while representing the tree, binary tree.
It is not a linked list actually. We can say a node is containing 2 pointers. Again, it is not a linear fashion. ये linear manner में नहीं है, आप देख रहे हैं.
Yes, sir.
Is it in a linear fashion?
No, sir.
No sir.
Non-linear.
तो ये linked list नहीं है. लेकिन still we are using the concept of linked list. So we are trying to manage all the nodes using linked list kind of structure. It is not a linked list actually. Linked list तो क्या होता है? तभी हमने यहाँ linked list नहीं बोला है, linked list representation. Linked representation बोला है हमने इसको, because it always linked all the nodes to each other. But it is somehow using the concept of the nodes that we have used in the linked list. So every node has 3 parts. One is information. In the structure, you are also able to see structure B node. Node का structure बनाया हमने binary node का. Integer information is 1 part. Struct B node left pointer. I think now it is okay to you all what is struct node type. Why it is of struct node type, left pointer and right pointer. Is it okay, or I need to explain it?
Sir, okay sir.
Now last one is struct B node root null. Root pointer we have taken as we have taken in the case of struct start. Linked list we have taken start now. Here we have taken root. So why? Because
Yes,
root is a terminology of this particular tree. So that's why initially the root node will always be null. मतलब initial level पर हम बोलेंगे root is null. It means tree is not there. So overall there is a pointer that is root also, which is the starting pointer of, which holds only the address of starting node. That's it. It will not have any other value. Is it okay now? Like linked list में हमारे पास start होता था, similarly we have here the root. That is what the linked representation means also. Again, इसका भी array representation ही होगा, जैसा कि हमने linked list का देखा था. Is it okay now? Yes or no?
Yes, sir.
Yes, sir.
Now tell me how many different arrays will be there in this. As in linked list, you have told me कि 2 arrays we have assumed, okay, for a simple node which have only one information and one pointer. So how many arrays we have for that in this?
इसमें भी सर 2 ही है, एक तो डायरेक्शन के लिए और एक डेटा एलिमेंट.
सर 3 एरे होंगे.
3 होंगे सर.
Very good. 3
Right.
arrays होंगे. Because one array is for information, one array is for left child, one array is for right child.
Right child.
हम 3 different arrays maintain रखेंगे, जैसा कि हमने पहले भी किया था. लिंक लिस्ट में आप लोगों को ध्यान होगा. This one, this 3 array, and this one is 3rd array. So suppose it is for information, it is for left child, and it is for right child. So one root will be there definitely. Root ने कोई एड्रेस होल्ड किया होगा. यहाँ पर हमारे पास A है, A का लेफ्ट चाइल्ड, यहाँ पर किसका एड्रेस होना चाहिए? इस पर्टिकुलर नोड का, B का. सपोज B यहाँ पर है, B का एड्रेस 2 है मान लीजिए, तो 2 होना चाहिए इसका एड्रेस. और यहाँ पर 4 मान लीजिए कि C का एड्रेस होना चाहिए. ये ध्यान आ गया? दैट इज व्हाट वी हैव डन इन द केस ऑफ लिंक लिस्ट.
यस सर, आ गया. आपने 2
Yes,
array
sir.
बताए थे.
हमने बहुत सारे एरो बना के बताया था ना.
हाँ,
2 यहाँ
same ही
जाएगा, फिर यहाँ से यहाँ जाएगा, फिर C
Yes, sir,
से
patient
will go
वाला.
to D. D कहीं यहाँ पर है तो यहाँ जाएगा, इसके एड्रेस यहाँ आते जाएंगे. मतलब अल्टीमेटली ये अवेल हो गया एक तरीके से. अवेल से वी आर टेकिंग द एम्प्टी स्पेसेस. So in this way we can represent the array into the linked list form. Is it okay now?
Can we save the address in different arrays also? Means we are saving the address of the right children in the left array and the left children in the right array.
Sorry, I am not getting you. You want to store the address of left child into the right array, right?
Yes.
Yes, sir.
It will be
No,
hard
no,
to understand.
no,
but can
no,
we-
no, no, no. Why? So you are changing the left child to the right child actually. Like suppose
Excuse
right now.
me, sir.
Right, एक मिनट बेटा. Suppose right now the D is a left child. You want to become it's as a right child.
No, sir. The previous of A means the initial node. Previous of A holds the address of C node, and the next of A holds the address of B node. Can we do that?
स्वैप कर रहे हैं, इंटरचेंज कर रहे हैं.
Not getting you properly again. Please repeat.
Sir, we are just interchanging the address of the nodes which we are holding. Means, sir, जो A का जो previous है means the previous.
Previous
node-
word you should not use previous
सर
word.
मैं बता दूं.
You should
Sir,
use
मैं
the
बता
left
address,
child.
the block
You
of
should
A
use the left child and you
address-
should use the right child. So in the left child array, you have to store the address of B node. In the right child array, you need to store the address of C node. You cannot interchange these addresses.
सर वो तो वही बात हुई कि हमने लेफ्ट चाइल्ड को सी बना दिया और राइट चाइल्ड को बी बना दिया. कोई बड़ी बात थोड़ी हुई सर.
Is it okay now? If the tree is this, so you will not change. Like you have to store the address of B into the left array and you have to store the C into the right array. यदि tree ये है तो, यदि tree दूसरा है तो फिर उसके according you can change it.
Sir, sorry to interrupt you, sir, but my phone is on 1%. Sir, can you mark my attendance?
Yes, I am marking it. I am taking the attendance. Okay, that is all I think for today. And we have studied about the various kinds of linked trees, and we have also studied about the representation of the trees. Now we will learn about the traversing of tree. We will start the operations of tree in the next class.
ओके सर,
Thank you.
कैसे
Thank
एलिमेंट
you
को
very much.